All right, this is going on page 99 when we're done. So the concept of inverse trig functions is not new to you. That is something that you did learn in geometry, something we've done quite a bit. If we have a trig value, we need the angle, we take the inverse, right? So, you know, if I say that the cosine, like what's the cosine of pi thirds? Cosine of pi thirds? 1/2, right? So then the cosine inverse of 1/2 is pi thirds, right? It's just going backwards and forwards. It's not quite as simple as that, but that's kind of the general consensus there. But a couple of little caveats when we get to trig stuff. So it says a function has an inverse if and only if it's a one-to-one function. To be a one-to-one function, you have to pass the vertical and the horizontal line test. So think about the graph of sine. It passes the vertical line test. Does it pass the horizontal line test? No. But we know that we've been doing sine inverse, so clearly it has an inverse. So here's where things change a little bit, and my jacket is still writing all over the board. It says, however, if the domain is restricted to a certain interval, the sine, cosine, and tangent functions have inverse functions. Okay, so that's why we get to have inverses, because we're going to restrict the domains. We are going to graph some of these because I want you to see the graphs and what's happening with them. This is not something that you're going to have to graph on your own. I've done that in the past, but I feel like that leads to a lot of confusion, and it doesn't really benefit anything. So we're just going to graph a couple together to kind of talk about it so you can see what's happening where, but then we're just going to use that information and move on. Right? So it says, when graphed on the restricted interval, the inverse of the sine function is the arc sine, which means we could write it as arc sine, which is the same thing as sine inverse. Okay, you can see it either way, depending on what materials you're looking at, who your teacher is, who your professor is, but they mean the exact same thing. The inverse of the cosine would be arc cosine or cosine inverse. And of course, the inverse of tangent would be the arc tangent or the tangent inverse. And then the same is true for the reciprocal functions, but we're not going to write all those out because hopefully you get the hang of it from here. Okay? All right, so arc sine, we're going to start by graphing a sine function over here. And so this is going to be a little bit better than a sketch of a parent function, but it doesn't have to be perfect and beautiful. But we're going to have 4 little hash marks on each side, because the better it is, the easier it is for you to see what I'm trying to get at here. And then, of course, we'll have a 1 and a -1. So for sine, I know that I started at 0 here. I end at 2 pi at a 0. There's pi, right? At pi halves, I'm at 1. 3 pi halves, I'm at -1. And then I can just repeat that over here. And then those are quickly my little points so that I can sketch something in that kind of looks like this. All right, so sine completely fails the horizontal line test, and it's because it's repetitive in nature. So the good news is it's not like we lose anything when we restrict the domain. And what I mean by that is this. If I start at 0 and I start to follow, which I don't know why it's not letting me do this, but I follow to here, right? If I kept going past pi halves, that's what's going to make it fail that horizontal line test, right? But the good news is from 0 to pi halves, doesn't this incorporate all of the possible positive y values I could get? Because on the way down, I just start repeating them, right? And then when I come back up again, I'm just repeating them again. So this right here is all of the positive sine values that I could possibly get. So if I keep, like I said, if I keep going, first of all, I fail the horizontal line test. Second of all, I'm just repeating what I already have. But if I go this way, like so, then that gives me all of the possible negative y values. You with me on that? Or negative sine values, which are the y values. So what I have here then is this is at pi halves, and this is at negative pi halves. So if I restrict the domain of my sine function, instead of saying all real numbers, which is what the actual function is, but I restrict it from negative pi halves to pi halves, I have a one-to-one function, and it includes all of the possible sine values I could have. So that's what we're going to graph right here, right? Sine, it even says I'm restricting it from negative pi halves to pi halves. So I have here at 0, I'm at 0. I don't know if this isn't calibrated or if I just can't hit the mark. There we go. When I am at pi halves, I'm at 1. When I'm at negative pi halves, I'm at negative 1. And so although what I drew over here has arrows, this definitely does not because it's restricted. And it's just this part of the function. Okay. For that part of the function, the domain, like we said, we restricted it. We're going from negative pi halves to pi halves, and I do include them because those are values. My range, I'm going from negative 1 to 1, and I do include them because they are values on the graph. Okay, we good with that? All right, so then this is the inverse. So this is cosine inverse. Remember when you find the inverse of any function, you're switching x and y, which means the labels on the x and y axis switch too. For sine, the x value is the angles. So for the inverse, the y value becomes the angles. Because here, our input is the angle, our output is the sine value. For this, our input is the sine value, our output is the angle. So they switch. When we go to graph this, we literally switch the x and y values. So I'm at negative pi halves, negative 1. So I'm going to go to negative 1, negative pi halves. 0, 0 is still just 0, 0. Pi halves 1 becomes 1 pi halves, like that. Those 3 points look like they're in the exact same place. It kind of looks like it would be the exact same graph, but it's not. If we graph some of the other not so pretty points, we could see this, but we also know that when we have an inverse function, it's also a reflection in the line y equals x. So since this reflects across the line y equals x, the curve flips around and it curves like that. Okay, you see how that's kind of a reflection right there? So now, just like x and y switch places, my domain and range switch places. My domain, I'm going from negative 1 to 1. My range, I'm going from negative pi halves to pi halves. So what that means for me is this. My input is any sine value I could possibly have. Now, if I said square root of 3 over 2, right? So would you agree that there's an infinite amount of angles that give me a sine value of the square root of 3 over 2, right? Because we can just keep going around the circle. Right, there's 2 and from 0, we can just keep going around adding 2 pi. We can get square root of 3 over 2 from an infinite amount of angles. We can go the other way. They're all over the place. But when I do the inverse, I only get 1. And that's it because I had to restrict this. The only place, because my output, my range, is from negative pi halves to pi halves. So what that means for me is this. My output answers can only come, negative pi halves is right here. This is pi halves. So they can only come from the first and fourth quadrants. Not only that, but I wouldn't say my fourth quadrant answer can't be 11 pi sixths because it's going from negative pi halves to pi halves. This is where the positive values come from. This is where the negative values come from. It actually makes it a little bit easier because if I say that I have a negative, let's see, what's the sine inverse of negative 1/2, let's say. So I know for 1/2, the sine inverse of 1/2 is pi 6. That's my reference angle, right? Because a pi 6 angle gives me a sine value of 1/2. Well, I'm coming from the fourth quadrant, but again, I don't have to think about it as 11 pi 6. I'm either going up and it's pi 6 or I'm going down and it's negative pi 6. You see how easy that is? Okay, so that's why we're looking at this to see where everything is coming from. These are my only possible outputs here going from negative pi halves to pi halves. That's it. Okay, questions? All right, let's look at cosine. So we're going to start again with sketching a little graph over here, if my pen will write. What is going on here? Okay. Oh, well, I'm still on the eraser. I'm just stupid. That's what's wrong. Okay. Here we go. As I'm writing all over this with my jacket. Okay, so again, 4 little hash marks. And then 2 on the y-axis so that I can get my 1 and -1. And I will erase what I think is my jacket doing that. Okay. So for sine, or cosine, I'm sorry. When I'm at 0, I'm at 1. So I have a point right here. At the end, which is 2 pi, I have another same y value. Halfway in between, I'm at -1. And then this isn't very to scale, but it'll get us what we need. And then I can sketch this. Okay. My y scale is like way off, but again, good enough for us to figure this stuff out. Okay, so thinking about this the same way, I'm going to start at 0. If I go from 0 to pi halves, that gives me all of the possible positive cosine values, right? I'm not going to go negative this way because that just gives me more of the positive. But if I kept going and go all the way to pi, this gives me all my possible negative values. So for cosine, I'm going to start at 0, and I'm going to go to pi so that I can get that restricted domain there. Okay? So when we graph this over here, I'm going to start at 0, which is at 1. At pi, I'm at -1, and at pi halves, I'm at 0. And then I know what cosine looks like, and the curve looks like this. My domain here, my x values, my inputs, 0 to pi. And yes, so I include them both. My range is still -1 to 1. So it takes care of all of my possible y values. Then we're going to graph the inverse. So again, the x-axis, which is our angles, becomes the y-axis, because our angles are our outputs now when we do the inverse. So I'm at 0, 1, so I go to 1, 0. I'm at pi halves 0, so I go to 0, pi halves. I'm at pi -1 here, so I'm going to go to -1 pi. All right. It's not only a, do I switch x and y, but it's a reflection in the line y equals x, so that causes the curve to go the opposite way. So then we can see our domain, our inputs go from -1 to 1, because those are our cosine values. The outputs would be the corresponding angles, and that's our range. That's going from 0 to pi. So for cosine, when I'm thinking unit circle-wise, my positive values are coming from the first quadrant. My negative values are coming from the second quadrant. Is cosine negative in more than just the second quadrant? Yes, it's also negative in the third quadrant, right? But when you're just purely doing the inverse, you will never get a third quadrant angle. It's a first or a second, and that is it. So that's why we're going from 0 to pi. Application-wise, we may need some other angles. We'll get there, but we're just talking the pure operation of what we're doing first. Okay? First and second quadrant. Fourth wouldn't make any sense because it's positive in the fourth also, right? We good so far? So with sine, if I ask you for an inverse or an arc sine, your answer could be a positive angle or a negative angle. For cosine, your answers are positive angles only. We good so far? Okay. Let's look at arc tangent then. So we're going to start off, we'll do our 4 little hash marks again. But this time, instead of going from 0 to 2 pi, it's going from 0 to pi. So I know at 0, cosine is at 0, right? At the end of the period, it's also at 0. Halfway between the two, I have an asymptote. It's a really thick one, but I'm just going to leave it like that. And so that means over here, I'd have it at the end, and then I'd also, oh, goodness. Then I'd have an asymptote here, too. Your asymptotes don't have to be that thick. I'm just not going to change it. All right, so then it looks like this. Okay, so we're doing more than just the parent function, just kind of getting a full couple cycles there. So what we drew for our parent function, we were graphing, because I was trying to stay consistent. I mean, there's different ways to do it. That was just kind of my way to help everything stay consistent. We started at 0 and drew from 0 to pi, which is fine, and that worked for us, right? But when we're looking at where are we going to get these values from, if I start the same way I did the rest, okay, so here, this gives me all of my positive tangent values. I want to skip over that. So to stay consistent with the rest, I'm either using first and second or first and fourth. Well, first and second don't really make any sense, so I'm going to do first and fourth. Okay? And when I say fourth, remember, I know that this is the third quadrant of what we're actually doing right here, but these are fourth quadrant angles on the unit circle, right? That's where we're talking about that. So this is going to be our this right here, that pink part that I drew, that is a one-to-one function. So we can graph that, and that goes from negative pi halves to pi halves, just like sine does. So at negative pi halves, I have an asymptote. At pi halves, I have an asymptote. At 0, I'm at 0. At pi fourths, I'm at 1. At negative pi fourths, I'm at negative 1. So this is my restricted domain of tangent, going from negative pi halves to pi halves. Do I include those this time? Is pi halves included or not? No, because they're asymptotes. Good. Range goes from negative infinity to infinity. All right, so now we have to graph arctangent. If I start at negative pi halves, so at negative pi halves, I'm undefined, which means over here, I'm undefined at negative pi halves, which is right there. At pi halves, I'm undefined, so I'm undefined at pi halves. Boom. Then at negative pi fourths, I'm at negative 1, so I'm going to go to negative 1, negative pi fourths. 0, 0 is still 0, 0. Pi fourths is at 1, so 1, we're at pi fourths. So remember, think about it as a reflection, and it just looks like, looks like tangent just sort of laid down here. All right, we good? So my domain here, my input is negative infinity to infinity. That's all my possible tangent values. Tangent's crazy and can be anything. Bless you. My range goes from negative pi halves to pi halves, not inclusive. So that tells me that I can only get my answers from first and second quadrant, going from negative pi halves to pi halves. Some questions you got at this point? Not sure why we're doing any of this yet. We're getting there. Okay, so let's rewrite some of that. So we know that for arc sine, which is sine inverse, I'm just writing it that way so that you have seen it that way. My answers can come from first and fourth quadrants. But when I say fourth quadrant, it's not an angle like 11 pi 6th, it's an angle like negative pi 6th because we are going from negative pi halves to pi halves. Okay, that's all I get to do there. Then my arc cosine. Cosine comes from first and second quadrants, going from 0 to pi. Those are the only two quadrants that I get to pull my answers from. That's it. Okay. So sine, my answer can be positive or negative. Cosine, you will never get a negative angle as an answer when you do this cosine inverse. Okay? Purely do the cosine inverse. We'll talk about what I mean by that in a little bit. And then arctangent. My answers are coming from the first and fourth quadrant because just like with sine, I'm going from negative pi halves to pi halves. Cosine is the problem child, right? Otherwise, we could be consistent. But if you try to pull the answer from the fourth quadrant of cosine, or for the fourth quadrant for cosine, it doesn't make sense because cosine's positive down there. Okay. All right, everybody good so far? Even though you might be a little unsure of exactly what it means at this point, and I know that, but okay. All right, so when I'm asking you for the arc sine or the sine inverse, what I'm asking you is, what angle gives me a sine value of whatever this is? So what angle gives me a sine value of 1? Pi halves, right? And pi halves is between negative pi halves and pi halves, so that's good. My answer is pi halves. Okay. Now, that was a quadrantal angle. Otherwise, I think about what quadrant is my answer coming from, first of all, and then what is the reference angle value, then what is my actual answer, all right? All right, so for number 2, this is a sine inverse of a positive value, which tells me it's coming from the first quadrant. Whether or not you make a note of that, actually write it down, that's up to you, but I'm just doing that so I don't lose you. So then I just have to ask myself, what angle gives me a sine value of the square root of 3 over 2? And you can use your hand trick for that as well. All you have to do is make square root of 3 over 2 happen where sine goes, and then this is your answer. What is it? Pi thirds. And since it's first quadrant, I put that as second quadrant. Don't ask me why I did that. Sorry. First quadrant is right there. And then my answer is just whatever that is, which is pi thirds. Okay. Arc sine of negative 2. What angle gives me a sine value of negative 2? Think about your parent function for sine, right? Not even the restrict, just that. When does sine have a value of negative 2? What is this value, sine value right here? 1. What's this one? Negative 1. Can you ever get a sine value of negative 2? No, because you can only go from negative 1 to 1. This just does not exist. Okay, make sense? All right, so little side note here. If I ask you for the sine of 7 pi 6, okay? So the first thing we think about is what quadrant is 7 pi 6 in? Third. Okay, so in the third quadrant is sine positive or negative? Negative. So this is a negative answer, right? And then, so then the sine of pi 6 is what? 1/2. So this is negative 1/2. We agree with that? Okay. So the sine inverse of negative 1/2 does not equal 7 pi 6. Okay? So I want you to think about that. The inverse of something is just doing the opposite. Addition and subtraction are the opposite of each other. So 5 plus 2 is 7, and 7 minus 2 is 5. We can go forwards, we can go backwards, they're the same thing, right? Going forwards, going backwards, these two things, not the same thing, right? The the sine inverse of 7 pi 6, here's what we actually do. Oh, I'm sorry, not this. That doesn't even make any sense. You have to take the sine inverse of a value, which is -1/2, which is what I meant to write. Okay. So the first thing I want to think about is, what quadrant is my answer coming from? I have, for sine, my answers can only come from the first and fourth quadrant when I take the inverse. This is where my positive values are. This is where my negative values are. So it's going to be a fourth quadrant angle. The angle that gives me a sine value of 1/2, the reference angle, is pi 6. So since I'm in the fourth quadrant, that makes this negative pi 6. These two angles aren't even in the same spot, okay? So be very careful just thinking it could be any pi 6 angle. It has to come from first or fourth quadrants. There are definitely times after we take the inverse, we will end up eventually with something like 7 pi 6 when we're doing the applications. We'll talk about that when we get there, but right now we are purely just doing the operation. It's kind of like if I said x squared equals 4 and asked you for x, you have to tell me x is plus or minus 2, right? It's not always both of them. Sometimes it's only one of them, sometimes it's none of them, but what you get algebraically is that, and then you figure the rest out from there. Okay, does that kind of make sense? So this is kind of weird at first, I know, but we have to remember that we're only getting from the first and fourth quadrants. All right, so with that said, let's look at number 4. Cosine of negative square root of 2 over 2. My cosine values can only come from the first and second quadrants. This is a negative value, so my answer comes from the second quadrant. The next thing I think is, what reference angle gives me a cosine value of the square root of 2 over 2? Pi fourths. Okay, so pi fourths is my reference angle, but I need my second quadrant pi fourths angle, which is what? 3 pi fourths. And this is my answer. Okay? All right, because remember, we're not getting negative angles from cosine inverse. All right, cosine inverse of 3. What angle gives me a cosine value of 3? None, because my cosine values can only go from -1 to 1, so this does not exist. All right, arc cosine of -1. What angle gives me a cosine value of -1? Pi. And we're going from 0 to pi inclusive, so pi is a totally fine answer. What questions you got? All right. I'm going to give you a minute. I want you to do 7, 8, and 9. Bless you. Okay. So arctangent of square root of 3 over 3. So the first thing I'm going to think of, again, whether I do this and write it down or not, but think about it. Tangent can only come from the first and fourth quadrants. This is a positive value, so this is a first quadrant angle that I'm going to have. So then I ask myself, what reference angle gives me a tangent value of the square root of 3 over 3? Pi 6. So then, since that's supposed to be first quadrant, my answer is just pi 6. All right, got another arctangent. It can only come from the first or the fourth quadrants. This is a negative value, so it's a fourth quadrant angle. But then I ask myself, what is the reference angle that gives me a tangent value of 1? Pi fourths. But since I'm supposed to be in the fourth quadrant, my actual answer is negative pi fourths. Okay? Does that make sense to you? Okay. Tangent inverse of the square root of 3. All right, tangent First and fourth, this is a positive value, so it's coming from the first quadrant. What angle gives me a tangent value of the square root of 3? Pi thirds. All right, so now I'm going to choose some lucky helpers to help all of us talk through the rest. She is not here. He is not here. Christopher. All right, so on number 10, what quadrants do my arc cosine values come from? 1 and 2. All right, so since this is negative, what quadrant are we coming from? 2. Very good. So then what reference angle gives me a cosine value of the square root of 3 over 2? Pi 6. Good. So since I'm supposed to be in the second quadrant, what's my second quadrant pi 6th angle? No, because that would be down here. I'm not talking to you. Just in general, my second quadrant pi 6th angle. Because remember, for cosine, arc cosine, we're not getting any negative values. You said pi 6. Yeah, pi 6. What's your second quadrant pi 6th angle? Okay, so how do you figure it out when you don't know? Okay, so guess we haven't been doing our delta math practice here. If this is at 0, this is at pi, so this is 6 pi 6ths. So what would your second quadrant pi 6th angle be? 5 pi 6. Okay, we good? All right. Alejandro. Tangent inverse of 1. So tangent, I can only get my answers from which quadrants? First and the fourth. Good. Which one is this coming from? The positive. Good. So what's the tangent? What angle gives me a tangent value of 1? Pi fourths. Good. Any questions about that? All right. Ruby. Arc sine of negative square root of 2 over 2. So what quadrants can my sine answers come from? What did you write at the top of your paper? One and 4. Okay, 1 and 4. This is a negative value, so what quadrant is it coming from? 4, okay. What reference angle gives me a sine value of the square root of 2 over 2? You can use your hand trick. You know your hand trick? Okay, put your left hand up and look at it. Okay, pi fourths is right here. This is sine. So what does this give me? It's the square root of the number of fingers over 2. How many fingers do you have there? 2. Okay, so I was just totally gave you the answer by doing it backwards, didn't I? You want to come up with this. Sorry. Kind of surprised I had to do this. So square root of 2 over 2 is right here, which makes this angle pi fourths, right? It's negative. What's my fourth quadrant pi fourths angle? Going from negative pi halves to pi halves. If I'm here, pi fourths goes this way. If it's negative, I'm going this way, which makes it what? It just makes it negative. Negative pi fourths. Okay. Oops. All right, negative pi fourths. Tomorrow, y'all are going to have a quiz, a timed quiz on your trig values, the whole unit circle. Okay. Number 13. Diana. Sine values can come from which quadrants? The first and the fourth. Good. And this one would come from which ones? The fourth. All right. What angle gives me a sine value of 1/2? Pi 6. Good. So this one, my actual answer here then would be what? Negative pi 6. Very good. Thank you. Probably is absent. Max. All right, arc cosine of 2. Cosine can only come from which quadrants? 1 and 2. And this is positive, so it's coming from 1, right? What angle gives me a cosine value of 2? None of them. That does not exist. All right, Daniel. Arctangent. So tangent can only come from which quadrants? First and fourth. Good. This is negative, so which one's it coming from? The fourth. Good. So what reference angle gives me a tangent value of the square root of 3? Pi thirds. Okay. So 1, 3 is pi thirds. Pi square root of 3 over 3, that's 2 3's, gives me a 6. Okay. So it's pi thirds. Since it's coming from the fourth quadrant, what's my actual answer? I'm only going from negative pi halves to pi halves. I'm only going from negative pi halves to pi halves. So I'm in the fourth quadrant, but I don't have to overthink it. What's my answer? But negative. Negative pi thirds. All right. On. Sine can come from, my sine inverse can come from which quadrants? First and fourth. This one comes from which one? The first. Okay. What angle gives me a sine value of 1/2? Pi 6. So my answer is pi 6. It's not negative. All right. Alex. Tangent can come from which quadrants? First and fourth. This one's going to come from which one? Fourth. Okay. What reference angle gives me a tangent value of the square root of 3 over 3? Pi 6. Okay. And then, so my actual answer here is what? Negative pi 6. Good. All right. 18. Here's F. Cosine can come from which quadrants? First and second. This is negative, so which one's it coming from? Second. Okay. What angle gives me a cosine value of 1/2? Pi thirds. And then my second quadrant pi thirds angle is? Yeah, because I'm going to the second quadrant. It's what? I'm sorry. 4 pi thirds. 4 pi thirds is going to be down here. So if this is 0, this is pi. So this would be 3 pi thirds. 4 pi thirds is right there. So what's the second quadrant? 2 pi thirds. Okay. All right. Number 10. Any questions on this? Number 10. A ship left port A and sailed 60 miles due east to port B. So I have starting and an end, and we're going 60 miles in some direction. So I got to figure out which side A is on and which side B is on. Reading what that first sentence says, what's on the left, A or B? A, because it leaves port A, drives 60 miles due east, which is to the right, which gets me to port B. From port B, the ship sailed 120 miles northwest, so we're going northwest, which is this way, and stops directly above, or directly north of port A. So that's going to make this a right triangle. And this is 120 miles. So it's asking me for the bearing from port B to the current location. So before I worry about the bearing, I need to figure out the angle in the triangle. This is just right triangle trig, so we don't need to make it any harder than it is. What trig function would I use here? Sine, cosine, or tangent? Cosine. So the cosine of theta is equal to the adjacent, which is 60, over the hypotenuse, which is 120. Which means that theta is the cosine inverse of 1/2. What is the cosine inverse of 1/2? This is positive, so it's coming from the first quadrant. Does that make sense? So it's pi thirds. Okay, good. Now, It's asking us, so that's a correct answer, but it's asking us for the bearing, and the bearing is traditionally done in degrees. So I don't necessarily want you thinking about this stuff in degrees, but once we get an angle that's a basic angle, we should know what that is in degrees. What is this in degrees? 60 degrees, okay? So then, let's think bearing. So when we do bearing, right, you can do it 2 different ways, and we're going to write it both ways. I can have that the bearing is, now I can do a northwest type of thing, which would be this angle right here, and this angle is 60, so what would that part right there be? 30, so we could say this is north 30 degrees west. Or I could do the bearing as a true bearing, which starts from true north and goes which direction? Clockwise, so I would go all the way around to here. So I can think about it as adding as I went around, but really I went almost all the way except for that 30 degrees. So it could also just be a 330 degree bearing without a direction. Okay. Questions about that? All right, then let's look at this last one here. We've got an angle of elevation from a football field to the crossbar, the goalpost. It depends on the distance from the ball to the base of the goalpost. So it says to write theta as a function of the distance. So this is theta right here. I can use right triangle trig again. Which trig function would I use here? Tangent. So the tangent of theta is equal to the opposite over the adjacent, right? Now this says write theta as a function of d. So this is very simple, bless you, but I want to make sure that you understand the wording. What this means is you're going to have theta equals something that has the distance in it. Okay, because if you don't understand what the words mean, it doesn't mean how good you are, it doesn't matter how good you are at the math. So I'm solving theta as a function of d would be just that theta is equal to the tangent inverse of 10 over d. Okay. And then the rest of it I just took off because it was irrelevant. But we're good on that? What questions you got? All right, so go ahead and get that taped in, and I will give you your assignment.